look at our chapter 8, basic integration rule. This one is a review of our chapter 5 from calculus 1. All this formula is on page 508. Alright, so the first formula and have an integral of k f of u du. You're allowed to take the constant out. K here is the constant, so you can bring out the constant and then take an integral of a function. The second property, if you want to add, subtract to function, take an integral, you can also take an integral of each part and then add and subtract them. The third one, an integral of du is equal to u plus c. Don't forget the c here is the constant. Number 4, if you have an integral of variable or expression raised to some power is equal to u n plus 1 divided by n plus 1 plus c. The fifth one, you have an integral of du over u is going to equal to ln absolute value of u plus c. Make sure you put in the absolute value because you want to make sure it's positive. Number 6, an integral of e to the u du is equal to the e to the u plus c. Number 7, an integral of a to the n du is equal to 1 over ln a to the u plus c. So let's look at our example here. My first example is over here. I'm gonna, as much as possible that I can apply one of this formula here. First thing I'm gonna do, I'm gonna rewrite it. I'm gonna bring out the 5 because I allowed to do it here from the first property. So I'm gonna bring out the 5. Alright, I'm taking out the 5. I'm gonna rewrite this as t plus 6 to the negative 3 dt. I'm just rewrite this as I bring it up, so it's going to be negative 3. And the reason I do that because I want to use property number 4. I have u to the n. My u here is t plus 6. My n here is negative 3. So this is going to equal to 5 t plus 6. I'm using this property here, so it's going to be negative 3 plus 1 over negative 3 plus 1 plus c. Alright, I'm using this property here. Now I'm just gonna simplify a little bit. Negative 3 and 1 is negative 2, so it's negative 5 over 2 t plus 6 to the negative 2 plus c. So that's the answer. Alright. Let's look at the second example. Alright, let's see example 2. Let's see this one. Let's say this is example 2. It doesn't fit any formula here, so I'm going to use the u substitution. Alright, I'm going to let my u is equal to 3x squared plus 6x. So that's my u. Then my du is going to be 6x plus 6 dx. Right? Okay, I have my u here. I want to have my du, so I can use property number 5. So I don't have 6x plus 6. I have x plus 1. So let me rewrite this as, I can rewrite this as factor out the 6. I have x plus 1 dx. Alright, so let's look at our original problem. I have x plus 1 over square root of 3x squared plus 6x dx. Alright, again, I have u here. Alright, I need the du, but I'm missing out the 6. So what I'm gonna do, I'm gonna do 6, and I have to multiply by 1 over 6. 1 over 6 times 6 is 1. Alright, so let's see. Since I'm doing this, I have 1, 6. All right, 6 times x plus 1 dx is my du. All right, that's my du. And on the denominator, I have u to the 1/2. All right, u to the 1/2. Let's see. Oh, I can use number 4. Now I see it. I can use number 4. So then I have 1/6 u to the negative 1/2 du. Right here. All right. So this is going to be 1/6. So since I use number 4, I'm going to add 1 to exponential. Negative 1/2 plus 1 is going to be u to the 1/2 over 1/2 plus c. All right, let's simplify a little bit. 1/6 divided by 1/2, that's 1/6. Oh, 1/3, sorry, 1/3. U, what is my u? My u is this one right here. 3x squared plus 6x to the 1/2 plus c. All right, so that's the answer. Or you can write this as square root, which is the same thing. Right? Let's look at the last example. All right, this last example here. I have an integral of 2/7 to the x plus 4 dx. So this one doesn't fit any formula again. So what I'm gonna do is I'm gonna take out the 2. I'm gonna take out the 2. So I left with 1/7e to the x plus 4 dx. All right. Let's see. What I'm gonna do, I'm gonna multiply top and bottom by e to the negative x. And I will explain to you in a little bit why. All right. I'm gonna multiply the numerator and denominator by e to the negative x. If I do that, let me draw a line here so we don't get confused with these two examples. Right? So I have 2 an integral of e to the minus x dx on the numerator. If I multiply e to the negative x in here, I will have 7 e to the x times e to the x, which is, e to the x times e to the minus x, which is e to the 0. E to the 0 is 1. So I would have 7 times e to the 0, which is 1, plus 4e to the minus x. All right? And the reason I'm doing that is I'm gonna let my u equal to, let my u equal to 7 plus 4e to the minus x. Now I'm gonna find my du. Derivative of e to the x is e to the x, and derivative of negative x is negative 1. So I'm gonna have negative 4e to the negative x. Alright? So look at this. I'm gonna have 2. This is my u. My du, I almost get it. If I have negative 4 here, I get my du. So what I'm gonna do is I'm gonna multiply by using this different color by negative 4 and negative 4 here. Right? Why did I do that? Because I want to have u du. Right? So let's simplify a little bit. So this is gonna be negative 1/2. All right, this is just my du. All right, my du over my u. Alright, my u. So I have negative 1/2 and integral du over u. So this is number 5. This is number 5. Alright, so that is going to be negative 1/2 ln absolute value of u plus c. Right? I have to substitute my u back. So it's negative 1/2 ln absolute value of 7 plus 4 e to the negative x plus c. So that is our answer. Alright, so I use first property number 1. I multiply by e to the negative x, so I can apply property number 5. And then I use property number 5. Alright, let's look at more example. Hi everyone, let's continue our 8.1 section. We want to see more example. The first section, I give you some property or basic integration rule, number 1 to number 7. Now we have number 8 to number 20. Number 8 to number 17 is all trig function, and then 18, 19, and 20 is something special. So let's look at example here. The first example, they want you to find an integral of x times cosine 2 pi x squared dx. So of course this is trig, so we're going to go straight to the trig, and we have integral of cosine function. So I'm going to see if I can use number 9. Number 9, integral of cosine of u du equal to sine of u plus c. So if I can use that one to make it work from our original problem, my u is 2 pi x squared. So I'm going to let my u be 2 pi x squared. Then du will be 4 pi x dx. Now I need to have cosine of u du. As you can see on number 9, I need to have cosine of u. I have cosine of u already. I need du. My du is 4 pi x dx. I have x dx, as you can see, x dx. I'm missing 4 pi. Again, pi is just a constant. So what I'm going to do is I'm going to multiply by 4 pi and 1 over 4 pi. Alright, because this two term is just 1. Then I would have an integral of 1 over 4 pi, an integral of cosine of u, right? Cosine of u, 4 pi x dx is just du. Then it's fit perfectly. Then it's equal to 1 over 4 pi. Because I run out of room, it's going to be sine of u. My u is 2 pi x squared plus c. Alright? Because I run out of room, this is just your u. I'm using this formula right here. Alright? So that's the answer. Okay, now let's look at the next one. I have 1 over 25 plus 4x squared dx. Of course, it's not trig. So we have to decide either 18, maybe. No, we don't have square root. It cannot be 18. 19, look like it might work. How about 20? I don't have square root. So I'm gonna see if I can make it to fit 19, right? So to make it fit 19, so my A would be 5, because 5 squared is 25, all right? And my U would be 2x, because 2x squared is 4x squared, right? So if my u is 2x, my du will be 2 dx. Alright, we try to make it fit this integral here. So let's see, I have an integral of 1 over 5 square plus 2x square, which is my u. Okay, my du is 2 dx. Okay, I have the x here. I'm missing the 2. As you can see, I'm missing the 2. So what I'm gonna do, I'm gonna multiply by 2, so I get 2 dx. Then I'm gonna multiply by 1/2. Alright, so from doing this, I have 2 dx, which is my du, a square, u square. Perfect. Then I can use the formula number 19, which is 1/2. 1/2 is from the front, 1/2 here, and integral of this will be 1 over a. So my a is 5. Okay, 1 over a, my a is 5. Odd tangent of u. I'm just, because I ran out of room, I'm going to use 2x here because my u is 2x. Over a, my a is 5 plus c. Alright, let's clean it up a little bit. So I have 1, 2 times 5 is just 10. Odd tangent of 2x over 5 plus c. That is my answer. Alright, we finished 8.1.